Let's learn in this video how to create a complete CI/CD pipeline within GitHub Actions to build and deploy applications into a Kubernetes cluster. During the build, we'll go to generate the Docker image, push it into a registry, and then during the deployment, we'll go to connect to an AKS cluster and then deploy our image using the YAML files into that cluster. And then we'll go to provision the infrastructure for our cluster using Terraform. So using Terraform templates, we'll go to create an AKS cluster and create a container registry, ACR. So I'll be using this repository from GitHub that is available as open source project, and I have already cloned this repository into my local machine, in which I have all the application files and source code files required for this demo. So here I have a sample web application that is an ASP.NET Core application that contains a Docker file and that I'll be using to deploy into my AKS cluster. And then I have here the YAML manifest files for Kubernetes. So those files contains the deployment and also the services, the persistent volumes, the secrets, config maps, and so on. And in addition to that, I have inside the Infra folder, I have a sample Terraform template that will go to provision the infrastructure for me. So this one will go to create a resource group, an AKS cluster, and then it will create also a container registry and assign the ACR pool role into my AKS cluster to be able to pull images from that registry. And they have here also some other Terraform configuration files related to this template. One of them here is the terraform.tf vars that contains the variables that I should replace when I want to deploy this Terraform template. So this will be deployed as part of GitHub Actions workflows, and here inside the folder.github/workflows, I have the second file, actions CI/CD AKS TF. This one will go to be triggered each time I have a new push inside the main branch when I change the YAML file for the workflow, and I can also trigger it manually. So this workflow will run just one job that will go to build the image, push it into container registry, and then deploy into AKS. For that, I need some environment variables, like here the image or the Docker repository. So here I'll go to push into Docker Hub and then the name of my image and the tag. Note here I'm using the run number, which is a predefined variable in GitHub that will be incremented each time I run a new pipeline. And then the resource group for my AKS cluster and the AKS cluster name that will be created by Terraform and the name of the Azure Container Registry, and here the version that I want to use of Terraform, which is the latest version per today as I'm recording this video, and then the working directory where I have here the infrastructure files used by Terraform. I am defining some defaults here, which are the run. Each time I run the command run, or I use the step run, it will use the shell bash, and then it will be pointing into the working directory, which is the infrastructure files. I use this actually with my Terraform commands. Let's see now what this pipeline will do exactly. So it will run the following steps. First, we'll get the application source code from GitHub, and then it will go to build the Docker image. So here it's using the commands docker build with the tag that we have specified before with the variables for Docker repository, image name, and the GitHub run number. Once that image is created, we'll go to scan it using the Trivi vulnerability scanner. So there I'm using the Trivi action and I'm pointing to that image from Docker Hub. And so Trivi will go to download that image and scan its OS and library, looking for any medium, high, or critical findings related to security issues. And then I'll go to log into the Docker Hub to be able to push my image later. So using the command docker login, providing the Docker repository and the password as std, and my password here is provided as a secret in my GitHub Actions. And we can see it here in Actions Secrets, and that is my Docker repository password. So by that, I'm ready now to go to push my Docker image into the registry using the command docker push and then the name of my image. Next, I'll go to change some variables inside my Terraform templates. So first, I'll go to change the Terraform variables inside the file terraform.tf-vars. Remember, those are the files that I need to change. So here I put just an alias for the name of these variables. So like the AKS resource group, AKS name, ACR name, and so on. And to replace those values from terraform.tf-vars, I'm using this task here, define it in GitHub Actions, that will allow me to look for any variables inside those double underscore. Note for that reason I'm using this double underscore, and inside those two double underscore I'm putting the name of the variable like AKS resource group. So the task will look for that AKS resource group and it will replace it with the value from here, which is the environment variable for AKS resource group that I have defined earlier as part of my environment variables for the pipeline. So it will change all of these values for me, and then I'll go to change or replace some other variables from my backend. So for this example, note here, I don't want to use the Terraform backend just for the simplicity of the demo. I don't want to save that backend into a storage account, for example. So to be able to do that, I need to go here to the backend.tf and change this value for Azure RM, change it to local. And that means I can run that backend from my local machine. So again, I'm using another task that will go to replace the string Azure RM with local. And then after that, I'll go to run the Terraform commands, but first I need to make sure that Terraform with a specific version is installed in my runner. So for that, I'm using the tasks provided by HashiCorp, setup Terraform, and here I'm providing my Terraform version number, which is an environment variable that again I have defined earlier in my pipeline, which is 1.1.9, which is the latest but today as I'm recording this video. After installing Terraform, I'll go to run Terraform init. So here, running Terraform init with the run step right here, I'm providing an ID for it, and then I'm providing the environment variables. So to run Terraform init, I need to be logged into my Azure subscription. So for that, I'm providing the environment variables that will be read by Terraform automatically. So either I log in with my service principal or with my identity or with a managed identity, or I can also use predefined environment variables that will be read by Terraform. So Terraform will look for these values. And here I'm providing all the secrets that I have already predefined in my GitHub Actions. So I have already created an SPN with these secrets for the RM client ID, client secret, subscription ID, tenant ID, and the credentials. I can show you that SPN that could be created with AZID create for airbag, and then providing the role name, which is owner, and then the scope, which is my subscription, and SDK auth, and the name for that service principal, and that will generate this JSON file that contains the client ID, secrets, subscription ID, tenant ID, and all the information you need to connect to the Azure subscription that will be used by Terraform. Now that I'm connected and I have run a Terraform init, then I'll go to run the Terraform format to format the files, and then I'll go to run the command Terraform plan in order to preview the changes that will be made by Terraform. And again, note here I'm providing also the environment variables needed by Terraform for the client ID and the service principal. After that, I'll go to run the command Terraform apply, again providing these credentials, and here I'm adding -o2 approve. That means here when I run Terraform apply, it will ask me if I want to approve to make these changes. So I need to type yes with my keyboard, and in order to avoid that, I can add the flag auto approve, and that will run without asking for my input. Next, here I'll go to prepare the YAML manifest files for my Kubernetes cluster, because I'm deploying a YAML file that have a reference to the image tag, which is the one that I have here, the image So I can provide a static number for that image tag, but because I'm creating a new image each time I run the pipeline, I need to change that image tag dynamically, and also maybe also change the image name and the Docker repository name. So to be able to do that here, I'm using a task to replace those values as I have done before with Terraform, looking for these values, looking for the tag, and then this task will go to replace that values for me, and thus it will generate a new YAML deployment file. After that, now I'm ready to connect to my AKS cluster using the credentials that I have provided earlier with the Azure credentials and the cluster name and resource group. So this is the equivalent of running AZ AKS get credentials, or the Kube login to the AKS cluster. Once I'm logged in, now I'm ready to go to deploy the YAML manifest files. So here I provide the manifest YAML files into the task or into the action called Kubernetes deploy. After deploying, I'll go to run kubebench, which is a tool for scanning the configuration of my AKS cluster. So I'll deploy it as a job in my AKS cluster. Then I'll wait a few seconds to let it complete the scan, and then I'll read the scan results in the logs, and then I'll go to delete that job. Let's see this pipeline in action. So here, switching to my GitHub repository, where I have the second pipeline, action CI/CD with Terraform. Here I can see that I have the latest one was succeeded, and of course not all the tries that I have done in order to make it work right here. So let's trigger this pipeline with the click on the button Run Workflow. So here I see that pipeline started running. If I click on it, I'll be able to see the job and all the steps inside that job. So it started first by getting the application source code, and then running the Docker build command to generate the Docker file, or to generate the Docker image actually. And here I'll switch to a complete pipeline that I have run it earlier. And in this pipeline, I'll find all the steps that did run successfully. So from building the image and then tagging that image, as we can see it right here. So that was tagged with the tag 44, and then running Trivy vulnerability scanner with the findings that are available in this table, and it did find here this CVE, which is of severity high. And then it will go to login to my Docker hub. So it tells me here the login was done successfully using the variables that I have provided, and then it will go to push the image into Docker hub, and here I have that digest file for that push. So if I go here to my Docker hub repository, I find here the latest image that was provided here for my web app. And then next here, it will go to replace the tokens inside the TF vars. So it tells me here it did find some variables that it did replace it, and it will do the same for the backend.tf file to replace Azure RM with local. And then it will go to install Terraform, the specific version 1.1.9, and then it will go to run Terraform init, and here it tells me the Terraform has been successfully initialized. After that, it will go to run the Terraform format, and then run Terraform plan to generate the Terraform plan right here that will preview the changes that will be made to my subscription. So here I have these changes previewed here. It tells me here it will go to create 4 resources, and there is nothing to be destroyed right here. So it will go to apply these changes later with the command terraform apply. So it will go to provision my AKS cluster and my container registry. It will assign the role ACR pool in order to be able to pull the images from my ACR, and then here it will go to create these resources automatically for me. This will take a few minutes, and after that those resources are created, it will go now to connect to my AKS cluster. Or first we'll go to replace the image name inside the MVC deployment YAML file, and then it will go to connect to the cluster with AKS set context, and it did created the kube config for that. and next here it will go to create the to go to deploy the YAML manifest files. So here it did deploy all these YAML files into my cluster. After that, it will go here to run or to scan the configuration for my cluster using Kubebench. So here I can see those findings. So it did scan the worker nodes, the kubelet, and here it did find some findings. So 14 checks did pass and 1 checks was warning. And that's it. So there are, of course, multiple ways to enhance this pipeline, one of which is to split it across different jobs. So we can imagine to have first job that will create the Terraform backend configuration, that will create a storage account and then save the Terraform state file into that storage account, and then create that infrastructure as part of another job right here, and then go to build and push the Docker container, and after that another job, fourth job, that will go to deploy the application into the Kubernetes cluster. Thank you.